Lesson 5 will be the conclusion to this training. We will do a brief overview of what we learned so that we can ensure that you can be as successful as possible with the 802.11 application framework. So the purpose of the 802.11 application framework is to provide a reference implementation of a common wireless standard. The application framework provides you with access to the source code, a modular and easily modifiable design, and a ready-to-run data streaming example. These are intended as a starting point for the implementation and validation of your new algorithms, systems, and testbeds. Again, some examples of how you could use the 802.11 application framework could be to experiment with 802.11 AX physical layer candidate modifications, explore better distributed MAC protocols, prototype better receiver algorithms such as synchronization, channel estimation, and equalization, or look at coexistence in combination with the LTE application framework. Again, all the source code is open and modifiable by you, so these are just some examples of what you could do, but really you could leverage this for any Wi-Fi related research. Using the application framework, there are two approaches for building your system. The first is what we call top-down, in which you start with the existing system and you edit it or add new modules, but overall you preserve the same similar type of architecture. Another approach is called bottom-up, in which case you build your own system using existing modules and submodules. For example, if you wanted to use the power sensing IP from the application framework for a different type of protocol, you could do that, and that would be a bottom-up type of approach. As a reminder, at a fundamental level, the NI software-defined radio platform provides a wide range of software-defined radio options and the actual software development environment from which to program the FPGAs and the processors and the data streaming between those targets. The application frameworks are add-ons on top of LabVIEW Communications and the USRP RIOs or Flex RIOs, which provide these ready-to-run starting points. In addition to that, there are free-of-charge application examples where we took the application frameworks and modified them for things like NS3 and LTE prototyping for software-defined network prototyping, or Wi-Fi and LTE coexistence, or even device-to-device communication, among many others. For further reading, check out the detailed white paper for Release 2.0 of the Wi-Fi application framework on ni.com. This has all the details that you need in addition to what we saw here to make sure that you are an expert in our implementation as it compares to the standard. There is also a Getting Started guide for the released version of 2.0, which is an HTML document inside of the project. These are also some other sources on the specifics of the wireless LAN protocol, which are a good reference if you are trying to familiarize yourself with Wi-Fi and some of its algorithms. My name is Rahul Brito, and I am a product manager on the Software Defined Radio team. If you have any questions with any of the training you saw today or anything else to do with our technology, please email us at labview.communications@ni.com. Thank you, and all the best in your future research projects.